Okay, that's good. Okay, good morning, guys. Any question about the exam or homework?
Good morning.
Hi, Evan.
I had a quick question about whether we would be able to see the statistics for the exam, like the mean or the standard deviation.
Okay, I can ask Professor Shaw. Yeah.
Okay, thank you.
I think the mean is around 20. Yeah.
The
But
mean was 20.
I did calculate it. Yeah. Yeah. Okay, I will ask the Professor. Yeah. Okay. Any more? Okay. This discussion 8. So today is about the hypothesis. Okay. So next is a summary, just copy something in the lecture. And I think the most important thing is like in this class we define a test as a set. So like you will be looking at this. So under some region is 1 and under another region is 0. Okay, so if the test is defined by a rejection region. And the most important theory is like the lemma-Pearson lemma. So it gives you a way to find a UMP test. And you have to be careful about how to choose a constant C, and how to be careful about when these two are the same. Okay. Okay, so let's do the question. So the question 1 just do the likelihood ratio test. So you have to calculate this and figure out in what constant C. I think you only have to reduce this to the form like this. Yeah. So you don't have to calculate the constant. Yeah. So in this question, they want to ask you to like the rejection ratio. Look at this. If the list is small, it's equivalent to this is big. Okay. Okay. So now please try to do question 1. Okay. I will do question 1 now. Okay, let's go to question 1. Okay, so we have the y1 y1 to yn. Now Bernoulli theta. Okay, and we want to test this the theta is greater than smaller than theta, okay, versus the theta is greater than theta, okay. Okay, and we want to find that ratio test. So we look at this. Is okay, let's say this is a likelihood function. This is another likelihood function. And in the numerator is the suprema over all the theta, smaller than theta, and then denominator is the theta belong all the space. Okay. So the denominator is easy because it's just a likelihood. So the theta should be S bar. Okay. Okay. But the numerator is a constraint optimization. So the maximum point may not be S bar. So you have to be careful about this. So let's look at this. The likelihood function is the M choose the summation of S yi theta summation yi 1 minus theta M minus summation yi. Okay, so find the solution for numerator. Okay, and let's find the log likelihood. That would be the log this plus summation yi log theta this log 1 by theta. And the same procedure we have to find the first derivative. So it's d log plus theta. And then this is equal to negative. So if we solve this, we can get the theta hat is S bar. But the question is the S bar may not in the domain like in the dual space, so it should be okay. So we'll be figure out why if the S bar is larger than theta nilo. Okay. Okay. And this we can find derivative again. Then you are seeing like this is and it's also negative. So this term is negative. So that means the first derivative is decreasing. I mean this. Okay. 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 I think it's not good. Okay. That means that this is concave. So if the S bar is greater than theta nilo, the graph maybe look at this. So okay, so that means in this case the theta nilo is the maximizer. So in the numerator, we may consider the solution theta hat as the minimum value of S bar and theta nilo. Okay. So okay. So now we have so we can have this is equal to let's say M2 summation yi. How about I write this first? So this is a theta hat y, a negative function, and a theta hat s bar y. Okay. And let's look at and choose y. So you may look at this theta hat summation yi 1 minus theta hat s bar. Oh, okay. So now we can cancel these two terms. And you can realize this is equal to 1 if the S bar is smaller than theta zero. But if S bar is greater than theta zero, then that will be much easier. So it will be like this. How about writing like theta zero S bar? Okay. So that means we only have to be consider this situation, because when this, in this case, the likelihood ratio is 1, so we will be failed to reject in any case, in any constancy. Yeah. Okay. So let's say about, so now we want to reduce the, so if okay, so we want to look like this. Okay, this is a lot of calculation. So the rejection region is should be like this. Okay. It's a rejection region. And we want to reduce this to a better form. Okay. So let's write this as the n times s bar. Okay. 1 minus s bar. Okay. So this is just a function of s bar. Okay. Okay. So this is a function of s bar. Okay. And we want to know whether this function is increasing or decreases in s bar. Okay. So if this is decreasing in s bar, so if gx bar is decreasing, how about gs bar is decreasing? Then the equivalence, then the equivalent rejection region will be s bar greater than something. Rejection region. So that's my goal. Yeah. So and the way to figure out is decreasing or increasing. We can find the first order derivative. Okay. Yes. See, we have no choice. So we have to find this. Okay. So let's say GT is equal to this. So it can be like the 10 exponential of the log exponential of mt log theta nino minus log t, and another term is plus n 1 minus t and log 1 minus theta nino minus log 1 minus t. Okay, so like this. So the first order derivative will be gt times the derivative inside. Okay, so next is m log theta nino minus log t, and the other term, this is plus mt divided by t, this. Okay, and the second term it should be negative m log 1 minus theta nino minus log 1 minus t. Okay. And we have to derive this again. So n 1 minus t, and this should be 1 minus t. Okay, like this. So you can see this two term can be cancelled. And we have equal to gt. Okay, so let's combine this term. Okay, so it should be n log theta nino divided by t minus m. Okay, let's say this minus log 1 minus theta nino. Okay. And the gt is always positive because it's a function of exponential. So what happened is this term. Okay. So we know that in here the s bar should be greater than theta nino. So that means t should be greater than theta nino. So the theta nino divided by t will be smaller than 1. Yes. So that means the log theta nino divided by t is negative. And this is all. This can also imply that this is greater than 1. And that's imply that this term will be positive. So the whole term is negative. Okay, it's negative. So the first derivative is negative. Okay, so we have the equivalent rejection region. S bar greater than some constant b is the rejection region for the likelihood ratio test. Okay. Okay. So let's complete our computer question. Okay. Any questions so far? So there are lots of calculation. Okay. So if not a question, we have 45 minutes. Okay. So now please do question 2. So you will have the same situation, like you may figure out the likelihood ratio test. The rejection region will be this. It will be equivalent to some function of t smaller than c. And you have to analyze this function. And you have to say, because the g have some property, then it's equivalent to the t smaller than c1, or the t is greater than some c2. Okay. So then I think that is usually the whole point. Yeah. Yeah, so the first step you want to figure out what is this, and you have to reduce to the form like this. And then you analyze this function. Okay, so let's take about 5 minutes to think about this question. Okay. Lower pulse. Okay, let's go through question 2. So first we have to figure out what is MLE. Okay. And we have the density is the, okay, it's terrible. Okay. It's equal to theta v theta divided by x to theta plus 1. And the domain is the, should be greater than v. Yeah, x should be greater than v, and all the parameter is positive. Okay. First, MLE. So let's find the IQ function. This should be the negative theta to power n, v to n theta, and the product of xi, and power is the negative theta, negative 1. And we have the indicator function, like the smallest value should be greater than v. Okay. Okay. So first, let's consider the v is smaller than s1. Okay. So we consider our domain is in here. Okay. So we can take derivative on the negative function. Okay. So consider. Okay. So our log negative function will be log v minus theta plus 1 log. Yes. So we can find the derivative. Okay. So let's derivative with respect to v. So this little, this v and theta, and this is little. Okay. So you can figure out this is always positive. Okay. So that is important because, so you can draw a graph. So here is S1, and the V So the curve might be look at this. Okay. But this is V, and this is a negative function. And this holds for AV theta. Okay. So AV theta, it may have a different function, but it always is positive. It always has a positive trend. So that means the S1 is the maximizer for V. Okay. So the V hash should be S1. Okay, so now we can plug in the V. Okay, sorry. V hash equal to S1, and we can solve the theta. Okay. So let's find the derivative of theta L times 1. That would be theta plus n log S1 and minus 4 times I. Okay. So you can say this is, we can solve this. Okay, I think let's reduce this form first. So it should be n theta, and it can be like negative this. Okay. And remember the t is this quantity. So that means this one is equal to t. So if we solve this, we can get the theta head is equal to n divided by t. Okay. Okay. So that's an MLE, but we also have to check the second derivative. Okay. So we have to check the second derivative, which is equal to it's negative. Okay. So we have an MLE S1 and theta head. And okay. Okay, so that's MLE. Any questions so far? Okay, so let's find the declaration test. So we are test theta equal to 1 versus the theta is not equal to 1, and V is unknown. Okay. So the declaration test, then will be like the numerator is plugging theta and V, theta equal to 1 and V is unknown. So okay. So numerator will be like this. The theta equal to 1 and V equal to smallest value. And the denominator will be theta equal to theta head. So it should be n divided by t, and V equal to S1. So where is the, oh, it's like this. Okay. So theta equal to 1. So this V S1 to the power n and product over Xi with negative 2. And here is n divided by t, and with power n Vs1 to oh, okay, that's weird. N squared divided by t. And also we have the product of Si of the negative n divided by t minus 1. Okay. Okay. Let's try to reduce this form. We have the, okay. So n to the power t to the power n to the power n, and S1 have the n to the 1 minus n divided by t. Okay. And the product of Si to have the power like the negative this plus 1 plus this minus 1. So it can be like the negative 1 minus this. Okay, then it look good. Then it look good because it can be like this. Product of xi divided by this to power n, and the power is negative 1 minus this. Okay. And this term is equal to exponential of t. Yes. Yes, because the t is look at this. Okay, so we will have like the t to the power n to the power n, exponential of the t negative t plus n. Yes. Okay. Okay, so let's look at our rejection region. Will be when this quantity is small. So the rejection region for the likelihood ratio test is like this. When this is small, and this is equivalent to, because these are all constant. Okay, to like the t to the power n exponential this smaller than another constant c. T to the power n, see, let me check. Okay. So we have this is a function of t, function of t. And we want to analyze this function. So the way we only know is we find the derivative of this. Oh, before we do that, let's look at this. So you can know that the G leader will be 0. Okay. and the G T go to infinity will also be linear. So we only have to figure out what happened in the middle. Okay. So let's find the first derivative of G. Okay. So it can be nt to n minus 1 e to negative t minus the t to power n e to negative t. Okay. Okay. Then you can figure out the G plus, okay, the derivative as zero is also zero. Okay. Why it doesn't look like what? Let's solve this first. Let me look at my hand. Why it didn't look at the same? Okay. My goal is I want to claim that the curve will be look at this. So if we want to find a cut point, the rejection region will be the left tail and the right tail. Okay. And theta is look at this. So the denominator negative function is this. So n to theta, t to power n, yes. And for the dollar term, it don't have theta, so it's like this. Okay. So let's solve this. So we can have the nt. Okay. Okay, yeah, this is solvable. Okay, so we can, because this is positive, so we can get rid of this two term. And then we only have to figure out, so then it's the n t to power n. Okay. And because t's are all positive, so that means this is equal to t. Yeah. Okay. So the maximizer will be on here. Okay. So we only have one solution. One solution. So that means the G will be, look at this. So G linear is linear and G go to infinity is linear. And where T is equal to N, will be like this. Okay. So if we give a cut point like the C prime, we will have the rejection region in here and here. Okay. So the rejection region for negligible test is will be t smaller than some constant c1 and t will greater than some constant c1. Okay. Next question 2. Yeah, so see the most difficult part is how to translate this one to the form look like this. Yeah, so this function g may not be increasing or decreasing, may not have some much more complex form. Okay. I only have 15 minutes, so let's do question 3. The question 3, we have a beta distribution. Okay. So that means the density of x will be look like this. Beta theta 1 at x to the power theta minus 1. Okay. X is below to 0 to 1. So this should be like this. Yes. For A, we want to find the size and power of the test. Okay. So we have a rejection region if the x is greater than 0.5. Okay. This is rejection region. Okay. So let's use the rotation like this one. Okay. So this is the probability we reject the region. Okay. We reject the rule. Okay. So the beta of the theta will be the probability of x greater than 0.5 greater than 0.5 condition theta. Okay. So this should be like the thing like this. 0.5 to 1 theta x theta minus 1 dx. So it can be x to the power theta 0.51. So it's 1 minus 2 to the negative theta. Okay. Okay. This look good. So we can draw a graph like the theta should be positive. So the x label is theta and y label is beta theta. So when theta is 0, then this is, the power is 0. And yes, and it can be, look at this, eventually it's 1. So it's an increasing function. Okay. So from this we can know that the size of the size is beta 1 because it's increasing. So we have to find the maximum value, just beta 1. So it should be 1 minus 1 over 2 over 2. And the power is okay. Okay, and for B, we want to find the UMP test. So we have to apply the Neyman-Pearson lemma. So the key we have to so first, because the beta function or x is continuous, so that means we don't have to care about the equal term. So don't need to discuss. Okay. Yes. Okay, so let's find a power test. Okay. So the f1x is equal to, so is theta equal to 2. So it can be 2 x to negative 3. 2 minus 1, so it's x. F little x is equal to, when theta equal to 1, so it should be 1. Okay. Okay, look good. Okay. So the rejection region will be like the f1 x greater than some constant c to this. So it can be like the 2x greater from some constant c. And this is equivalent to the x greater than some constant. Okay. So next is rejection region for the UMP test. Okay. By the Navier-Pierce lemma, this is a rejection region for UMP test. So we only have to figure out C to measure the significant level is alpha. Okay. So the C can be, so alpha should be equal to the probability we reject condition on the rule. Okay. So that is equal to C to 1 dx 1 minus C. Okay. So the C should be 1 minus alpha. Okay. Okay. So the UAB test for alpha is like the S greater than 1 minus alpha. Okay, that's all. Okay, and any questions for the discussion or the exam? Oh, sorry.